The next important part is current industrial revolution, that is the industry 4.0. So anyhow, most of the industries in India not yet adopted industry 4.0. Still we are working on the third generation, that is 3.0. So what is 4.0, that we'll try to understand. So just go through a few slides, you will understand the progression of the various industrial revolution and why this industry 4.0 is important, and industry should quickly adopt this technology to maximize their product, maximize their profit. So it is very interesting thing. So this is the 1.0, that is industrial revolution 1. So that was during 1760 to 1840, where we used to have mostly the mechanical production, railways and steam engines. So first time we started using some mechanism to just automate the operation. So that is considered as a 1.0. Then in 2.0, that we started using electric motors. You can see this picture, this 2.0, this electric motor. Earlier it was driven by the water or by hand driven. This you can see, this is the example of the hand driven machine. This is water driven machine or the wind machine you can take. So that was the 1.0. When 2.0 we started using motors. But at that time we had only the control to start and stop. You can see this is the starter where we are having only two buttons, start and stop, but we cannot control the speed of the motor or some safety measures we cannot incorporate it here. So that is the limitation of 2.0. Then in 3.0 we started using computers, semiconductor, mainframe computing, personal devices and PLC first time, and internet also. So this is considered as a industry 3.0, and you can say this is the industry 1.0. This is simple animation. So most of the operations are manually done, but with the help of some mechanism, and that mechanism is driven by either the pressure or by wind or by water flow, etc. This is industry 2.0. So you can see here industry 2.0 that we use some automatic, that is electric motors, to move the conveyor belt, and on conveyor belt we are having the different cars. So like that it can be painted using robots, and all these operations are nothing but the 2.0. Then this is the 3.0, where the person is not directly involved. So person is sitting on the computer and programming it and just giving the command. So this robotic arm is executing the task. So this is industry 3.0, where we are using computer as a control device. This is the industry 4.0, just giving the commands to the multiple robotic arms. It will perform the operation as per the programming and as per the requirement. So just you go through this picture. In this picture all four generations are described. That in 1.0 we started using mechanized production, that is steam engine and all. Then the mass production, assembly lines, electricity, that is 2.0. Automation, IT, electronics, that is 3.0. And now we are in the fourth generation, that is connectivity. Means the smart technology will be using to connect each machine, so that machine to machine or machine to human and human to machine communication will be possible. And for getting achieved, we need these technologies, that is the cloud computing, big data, network machines and processes. So what are the important components of industry 4.0? So the first important part is cyber physical system. Then Internet of Things, smart factory and Internet of Services. So in cyber physical systems we will be covering devices like RFID, development of sensors, actuators and integration of sensors and actuators. Then in Internet of Things, that is machines such as mobile phone, sensor, which can communicate each other. So that is taken care in Internet of Things. Smart factory is all about the physical world as well as virtual. Such
Business, science, and politics are working together to make Industry 4.0 digital and decentralized production processes. Comprehensive digitalization will decrease production costs, be resource efficient, and customer-oriented. At the same time, new business models, innovative products, and new services will be created. Machinery and plant engineering, along with the electronics industry, internet-driven, self-controlling, and sensor-aided production systems will shape the future of the machines. Based on cyber-physical production systems, orders will be able to steer themselves independent methods for analyzing digital industrial application data. In the future, production will involve machines and objects being equipped with sensors that continuously collect data about status, location, work status.
Customers. This results in an increase in productivity throughout the lifetime of the product.
In future production processes, man, machine, and product will be communicating with each other, allowing for a self-organized production process. The product itself will become the crucial information carrier. By using Industry 4.0 technologies, they will autonomously decide where and how they are produced. Throughout Germany, communication between all production processes, ranging from supply to delivery, can be optimized and in the Internet of Things, products and devices are automatically identified by intelligent sensors. They are linked to each other via the Internet. In this way, valuable information is obtained and analyzed. However, the security of this information is essential for a successful and efficient Industry 4.0, and a key issue for the German research institutes are amongst the world's leading pioneers in taking on the challenges of Industry 4.0. The German Research Center for Artificial Intelligence and the Smart Factory Kaiserslautern have partnered with industry to build the first cross-vendor Industry 4.0 installation.
Analyzing and correlating these large amounts of data.
For the government of the Federal Republic of Germany, Industry 4.0 is a key element in securing Germany's status as a manufacturing location.
The federal government...
Investments amounting to 40 billion euros are planned by the year 2020. Within the next 5 years, more than 80% of German companies will fully digitalize their value chain. Experts expect an increase in efficiency of 18%, and cost reduction of about 13%. Through innovative new products, new services, and new business models, an additional growth potential of up to 425 billion is expected by the year 2025. Let's shape the future together and be part of the fourth